Hey guys, what's up? My name is Gabe and this is Games with Gabe. This is the next episode in the Coding Geometry Dash in Java series. In the last episode, what we got to was we are now able to select objects by clicking on the different objects, and that was the hard part. Now we get to the easy part, which is actually manipulating those selected objects. So doing things like pressing the arrow keys to move them around the screen, and then pressing Control D to duplicate the objects and then replace them in the same place, and then adding in controls to change their z-index, so making them behind or in front of other objects. And lastly, rotating the objects by pressing W and D, which would be like sort of right rotation, left rotation. And those will be the basic, level editor functions that you might want to bind. You could also bind other functions. This will sort of just give you that basic idea of how to do everything. And then in the next tutorial, what we're going to cover is box select, which is very similar to the selection thing that we just did, but a little bit different because instead you can click and drag and select multiple objects at once. Technically, you don't really need it, but when I was editing and actually started making a level, it is so useful. It's something you do want to have. Let's implement these simple level editor controls now and get this done, okay? Like I said, in the last tutorial, what we got to was the ability to select multiple objects, change the selection of the objects, and more with this ability. One thing you might want to add is if you click onto an object that's already selected and you want to deselect it, then it deselects it, so it's a toggleable effect. Consider trying that as like an exercise. Next thing we want to do, though, is enable it so that when we select the objects and hit the arrow keys, we can actually move these objects around. This is actually pretty simple. It's really not that bad. I try to refrain from saying it's pretty simple because usually I say that and then it's actually kind of difficult, but this really is not that bad. So I'm going to switch my view mode real quick so that my text is actually readable, and then I'm going to go into the class level editor tools, the thing that we were working in last time. All right, so I'm back in level editor tools. Let's just go down to our update method. This is where we're going to be primarily working in. First, let's add in a couple functions that we will be using. I'll just add it right down here. And this is going to be our move objects. And then we'll take in a direction, and we'll just call this direction. And then we'll go up to the top of our class and create something very simple. So inside here, we'll just create this. Well, actually, we'll create it right up here. We'll just call it private enum direction. And this is, you can have up, down, left, and a right. And all this is Java's way of so it's an enumerable object, enum. And so this is basically just like 0, 1, 2, 3 is what it compiles down to. It just makes it so that we can read things like up, down, left, and right, which is a little bit better for us. So this way we know which direction they are trying to move the objects in. Then we'll say we'll just say switch on direction. And we'll say case direction dot up. We do one thing and then we'll break. We'll say case direction dot down. We'll do one thing and then we'll break, and we'll get to that error in just a second as well. Let's just add in the last couple and then break and case direction dot right and break and default and break. Okay, and then what's this saying is an enum switch case label must be the unqualified name of an enumeration constant. So all that's saying is basically we can't have that direction. So it has to be something like that, which we can do very simply. The reason it knows that too is because you see we're saying switch on direction. So it knows it's a direction object, and it's just saying, hey, you don't need to put in that qualifying direction. We already know it's a direction object. So we just need to say up, down, left, or right. And it takes in all the cases. Next, what do we want to do? Well, if they're trying to move the objects up, we want to move them up by one tile, right? So we just say for game object geo in our selected objects. Then, actually, let's do this outside of this switch loop. So I did not prepare this too. This is all just, usually I prepare my episodes. This one is literally just going and doing things because I figured this one didn't really need much preparation. So we'll loop outside of this, and then for each game object, we'll say, okay, if the direction is up, then we'll say geo dot transform.position.y plus equals, and then we'll just do a tile height. So we will move it up by 1 if it is down. And actually, remember, this is weird because Java in swing, up is down, down is up. So we just have to flip that. So we subtract actually the tile height, and then we add the tile height to go down. And then for left, we'll say transform position.x minus equals constants.tile width. And we'll just copy that guy. And if we're going right, and then we'll go plus equals. And default, we will say system.out.println. We should never get here if we're getting a direction object, but just in case we do, error direction has no enum, and then we'll just say plus whatever this direction is. And then we will do a system.exit -1 because this is an error we should never ever get into here. If we somehow do, then you might have modified this guy on accident, so that would be worth knowing for sure. But yeah, let's add in one more thing too, because in Geometry Dash you have the ability to move it full block or just a little bit of a direction. So then we'll also put in float scale, and this scale will always be set to 1 initially. So if we just multiply all of our distances by scale, then this will change the amount of distance that we are moving. And what this will do is, so if scale is 0.1, then this will move a tenth of a block. If scale is 1, this will move a full block, so on and so forth. There is a problem with this because of floating point numbers, which we will see in just a second, but let's hook this up real quick and see if everything works. We're going to notice a few different things actually. So first, we'll just simply say if window.keyListener.isKeyPressed vk.keyEvent, or I mean key event dot vk left. So left arrow key is pressed. We just say move objects in the left direction. So direction dot left, and scale is 1.0 f because we're not going to be moving that anymore. Let's just copy this whole thing actually, and then we'll say else if, and then else if. Whoops. And then we will just change this to be right top bottom, right top down, not bottom. I'll do that real quick. You guys can do this yourself. All right, so we have all the plumbing in place. Let's try this out and see if it works. If we go back into our level editor scene, we'll place a few objects, and we're like, whoops, we placed these in the wrong place. We want these to be on the bottom. So we'll press the down arrow, and you see our first issue. So this is running every frame. There is no debounce associated with this. So remember how we had the debounce, the mouse click? Well, this is the reason why. We're running at like 60 to 100 frames per second right now. So if you press up for just a couple milliseconds, it's going to move not once, but possibly 4 or 5 times, because you're going to be hitting 5 to 6 frames every time you just barely tap it. And if you hold it down for longer, you're going to be moving quite a bit of frames. So we have this thing called a debounce, which is just sort of to our reflexes. If you're holding down, we know you're probably intending to move it several, so then we'll let it keep going. But if you just tap the key, we're assuming that you don't want it to move several different places. So we will add in this debounce, which will be like, we'll give the person like 0.1 seconds to realize. So we'll say private float debounce key equals, and we'll do 0.2 seconds again, see how that feels, and then private float debounce key left equals 0.0f. And I spelled that wrong, and we will go back into our scene, and our update loop, we'll do the same thing for our debounce key, just subtract dt, or actually for our debounce key left, so we'll say if debounce key left is less than equal to 0 and this. And then we will add this in to all of these. Whoops. And then I'm just going to copy all this. And we will just add this in here and add this in here. And then we'll say is debounce key left equals debounce key. We'll just do that. And then we will place in a few blocks again. Select them. I put them in the wrong place. I can now move them at one at a time, and if I hold down the key, they move pretty fast. Like, I think that's good enough for me. If I hit escape, then, or just move my mouse, click somewhere else, then it deselects them. But now we can move the objects. That's great. That's one of the things we're looking for. Let's add in a moving them with a small increment. I think the best way to go about this will be to create a variable up at the top, and we will call this private boolean shift key pressed, and we will initialize this to false. This will tell us if the user is holding down the shift key. And how do we check for that? Well, we just say if window.keyListener.isKey pressed, and then we'll say vk, or actually key event.vk shift, then shift key pressed equals true, otherwise else shift key pressed equals false. So this will let us know if the shift key is pressed, and then what we can do inside here is we can literally just say scale is 1.0f, but then we can say shift key pressed, is the shift key pressed? Then if it is, we'll do 0.1f, otherwise we'll do 1.0f. This is just shorthand if-else statement. This is called a ternary statement. You can look it up if you're a little bit confused. It is a kind of esoteric syntax that is used occasionally. It's very helpful in times like this. All this says is the shift key pressed? If it is, then we do 0.1, otherwise we do 1.0, which is exactly what we want. So if they're holding down the shift key while they move, then we will move it only a small increment, which is a 1/10 of the block, which is what I counted when I was doing it. And this is where we will see our first problem. So actually, I'll put that here and I will put this here. If we go 10 times 0.1 times 10 is 1, so we should move a full block level up. I'm holding the shift key. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Uh-oh. Look at that. They are uneven by just a little bit. Why is that happening? Well, that's because of floating point round off error. And what this is basically just like a computer can only hold so much memory in place. So when it's doing calculations, it is not 100% accurate. It truncates it, it cuts it off. And that round off error, that stuff that it cuts off, builds up over time, so that once you move 10 blocks, it gets bad. Once we move 20 points, it gets really bad. And then once you move 30, it gets worse and worse until you're just getting very, very off. And so we can fix this by doing a modulus. So if you remember, modulus is like 5 mod 1, or actually we'll do 5 mod 3, basically returns the remainder of what you have. So I was looking at my old code and it looks like I did a few things a little bit differently. First of all, let's do this one little optimization that will help out a little bit. We will create this vector2 called distance, and then we will say the distance equals a new vector2 0.0f 0.0f, and then what we can do is, instead of doing this switch in here, what we'll do is we'll grab this switch and move it outside, and we'll say if it is this distance, then we will say distance dot y equals constants dot tile height, and down here we'll just do the same thing. So if we're going down, it is negative tile height, and then if we're going left or right, it is the x, and we change that to the tile width or negative tile width. So we'll change this to tile width, and then copy that and copy this, and then we'll change this to positive tile width. So this is just a little optimization, and then we can loop through the game objects in here because we are going to change up the way we're doing this a little bit because of that error that we just saw. First of all, let's add in a bracket down here. And then what we can do, so now this vector contains the distance that we should be moving up or down or left or right. And what we can do is we can say go.transform.position.x plus equals, and then we'll say distance.x, and then go.transform.position.y plus equals distance.y. So this will officially move them just like we were doing before, but now we can deal with that round off error just a little bit better way. Then next what we're going to do is we're going to get the grid X and the grid Y similar to how we have done in the past. So we'll say float math.floor grid, we will say go.transform.position.x over, and then we'll say constants.tile width, and then we will say times constants.tile width. And this is just literally getting the X position or the X line that we are currently on in world coordinates. And then we'll copy that, paste it, and then just change all the X's to Y's. And we could change tile width to tile height, but technically they are the same, and I don't see that changing anytime in the future, so we'll leave that as is. And then what we can do is we can say if the goes transform position.x plus 1, or actually we'll say is less than grid x plus 1 and go.transform.position.x is greater than grid x minus 1. So if it's like right next to the grid x, what we'll say is go.transform.position.x equals grid x. We will just snap it to that position. And then we'll do the same thing for the y. So we'll say if the position's y is less than grid y plus 1 and go.transform.position.y is greater than grid y minus 1, we will once again just snap it to that place. So we'll say equals grid y. In this way, if we're close enough, we can just snap it. We can't really do modulus like I was talking about earlier because it just doesn't work in this case. Java doesn't support floating point modulus in a good way. And it wouldn't really be helpful to us anyways because it's not exactly what we were looking for. But if we run this again and we just place in a few blocks, I'll put one down here. And then if I move this down 10, well, first of all, something is wrong. So because when we went up here, this should actually be negative, and this should be positive, and we should multiply everything by scale. So make those changes if you haven't already when you were watching me do this, and we will run this one more time. And then if I place the blocks in, and if I move this 10, this is the 10th one, notice how it snaps. Okay, there we go. And then it snaps into place so that it is perfect, but we can still move it a 10th back and forth. And this will fix those errors. Now, if we just move this 10 down, you'll notice that it works perfectly, and I can't move left or right. So let's fix that too real quick. One more bug. Change this to X's. Okay, there we go. Now we should be completely good. And if we place in 2 blocks here, I can move this one left and right. So that should about fix it, everything up. And we have one more bug here. So it turns out it was just an off by 1 error. If you change this to +1 and then end the parentheses there and leave that just as it is, that will fix it. We were actually checking the grid line directly to the right of the object. So that was not completely correct. And then if we go back and try this one more time, you will see that it works perfectly fine and they snap together. So this is for moving objects, and then for duplicating objects, it's actually pretty simple. We can just say public void duplicate, and this will literally just say for game object geo in game objects, selected game objects, geo.copy. It's really simple. And then what we can do is we can say if debounce key left is less than or equal to 0 and window.keyListener.isKey pressed, and then we will say key event.vk, this is D, so if the D key is pressed and if window.keyListener.isKey pressed, key event.vk control. So if the control key and the D key are pressed, then we will just say duplicate, and then we will say debounce key left is equal to debounce key. And that should solve that. So then if we go and we select a bunch of objects, and this will also work pretty cool because the selected objects we have will remain selected. So if we hit Control D and then move up, well, that didn't work. Oh, and the reason we weren't seeing anything is because we forgot to do window.getScene.add game object go. So we copy the object. Well, actually, let's do go.copy inside here. So we copy the object and add it to the scene at the same time to be rendered. So we were copying objects. They just weren't actually being added to the scene. So we'll go 1, 2, 3, 4 here, select them all, and then hit Control D. And if we move them, you can see that we have duplicated the object successfully. And the reason that it stays selected is because the objects that we have selected then are actually the same objects that we copied, and the copies are staying in the same place, but it works out just fine for us. And then lastly, rotations, which I think we'll get to in the next video because this one's running on for a little bit too long, and we'll do box select in the next video as well. But this is the basics of creating, you know, hotkeys and stuff, and it really does just go like this, where you add in a key binding to your update method and then just create a function that does stuff with the objects that are currently selected. That covers it for this tutorial. I hope you guys liked it. If you did, please hit like and subscribe, and I will see you in the next one where we will implement box select and rotations. Thanks, guys. See ya.